Hello and welcome back to our course. We are on the second part of our video of taking quantities. We covered the first part. In the first part, we covered up to the brickwork that is computed in a building, and we are going to continue the rest of it in this video. So previously, we had done the measurement, the computation of the quantities up to the brickwork and superstructure. Now we look at the RCC in slab. So we are meaning the roof slab here. So for this, we will have to look at the dimensions of the roof slab. Let's check the elevations and the plans for this. So in the roof slab, we saw the dotted line around the plan that represents the roof slab. And we know that up to the wall, the end of the wall is 8.2 meters. And we also saw in our section that the roof slab projects by 0.1 meters on both the sides. So for our dimension purpose, the roof slab would be 8.2 meters plus 0.1 on this side and 0.1 on this side. So it would be 8.4 meters as length. Similarly, when we look at the width of the room, we have the outer wall to outer wall as 4.2 meters. And then we have a projection of the dotted line, which represents the roof slab, is at 0.1 meters on both sides. So the dimension of the roof slab would be 4.2 plus 0.1 on one side and 0.1 on the other side. It would be 4.4. When we look at, we've got two dimensions, the length and the breadth of the roof slab. So in this we can see it's 8.4 meters, which is outer to outer edge of the roof slab. And the thickness of the roof slab is 0.1 meters. So we've got three dimensions in place. Let's look at the Excel sheet now. So the RCC in slab is 8.4, which is the outer dimension, and with outer length, and 4.4 is the width, the breadth, and the thickness of the slab is 0.1. So we've got the dimension as 0.1, 8.4 into 4.4 into 0.1. Next, we look at the item RCC. So the RCC is, we know that RCC is reinforced cement concrete. RCC in lintels over D1 and W1, both on door 1 and the lintels on doors and windows are computed as separate items. We first look at the item door, and we saw in our plan there are two doors, so the number is mentioned here as 2. And now what we have to look at is the length, breadth, and height of the lintels above the door. So let's look at the drawings now. So in the drawing we have the length of the lintel band, the RCC lintel band as 1.3 meters. We also have the depth as 0.1 meters. What is the width? To understand the width, maybe we will look at a schematic representation of lintel so that we get an idea of how to find the width of the band. So we have got two dimensions here. One is 1.3 meters and the thickness 0.1 meters. We are going to look at the third dimension. We have an example of a lintel beam here, and it has got a projection from the lintel beam. For our understanding, we're going to be focusing on this portion. So we have the thickness of the lintel, and what is the width? We see that the width of this is the same as the brick wall thickness. In our case, we know that the brick wall is 0.2 meters thick, and so for our purpose, the lintel would be the width of the lintel would be 0.2 meters. We'll look at this in the Excel sheet. So we're back to the Excel sheet and the RCC in lintels over D1. We saw how we got the dimensions 1.3 and 0.1, and 0.2 is the brick wall thickness, which is the breadth of the lintel itself. The lintel is in flush with the brick wall. So we have the quantity, the different dimensions of the RCC lintels over D1. Now we look at the next item, that is RCC in lintels over W1. The window, we will just take the dimension over window 1 because it's a typical window and it gets repeated 4 times. So we take the number as 4 And now let's look at the dimensions of the lintel beam over W1. So we will go back to the drawing. So in our drawing, we see that the lintels over windows and doors are the same. So we have, for the doors, it's 1.3 by 0.1. It's the same as the lintel, 1.3 by 0.1. So we have common lintels over doors and windows, common type of lintel, I mean. And so we can take the same dimensions as we took earlier. So the window and door lintels are of the same dimensions. Therefore, RCC in lintels over W1, it's 4 numbers. Cubic meters is a unit of measurement. Length is 1.3, breadth is 0.2, which is the brick wall breadth, and the height is 0.1. Next, we look at the plinth filling under floor. And the first item under that is the rammed earth. So let's see how the rammed earth measurement is taken. So for this, we'll again go back to the section drawing. So we are on the section drawing, and we have the outer dimension of the room as 8.2 meters, which we had seen in our previous in the plan. So the dimension from the outer wall to the outer wall is 8.2 meters, and for the purpose of filling, we have to exclude the brickwork that is on both the sides. So the total brickwork is 8.2. The outer dimensions of the brickwork is 8.2, and we have to subtract 2 brick thickness to get this rammed earth. So for that, we have to subtract 8.2 minus 0.2. Again, we will subtract the other wall thickness, which is 0.2. So we get it as 7.8 meters. So we've put in 7.8 meters as the length. Now let's look at the breadth. To find the breadth of the earth filling, the rammed earth, so we're looking at the building from this side. We have the outer dimensions as 4.2 meters, outer wall to outer wall. And what we have to find is that we saw in the section that the brickwork, the width of the brick wall on both sides will be deducted. So basically, we'll be only having the internal dimensions of the room because that is the only area that we will be filling with earth. So for that, we have to subtract from the outer dimensions of the width of the room, that is 4.2. We have to subtract 0.2 on one side and 0.2 on another side, which will be 4.2 minus 0.2 minus 0.2, and that will be 3.8 meters. So we have 3.8 meters as the breadth of the rammed earth under the plinth filling. Now, how do we find the dimension of the plinth filling in rammed earth? For that, we will refer to the section drawing. In order to understand the thickness of the rammed earth, the height that we have to find out, what we refer to is a section drawing of the foundation. So in the section drawing, we see that the rammed earth is from the ground level to 0.38 meters level. And so this is the level of the rammed earth. So this is the thickness, this is the quantity that we take to our Excel sheet to find out the total quantity of rammed earth. So we carried on the 0.38 meters onto the item rammed earth. So 7.8 into 3.8 into 4.38. The next quantity that we are going to look at is the sand filling under floors for 150 mm thickness. Again, sand filling, like in plinth filling, we are going to take the inner dimensions of the room. So we carry over 7.8 and 3.8 as we did in the previous item. And what remains to see is what is the height of that particular item, sand filling. We've seen that it is 150 mm thickness, and we can get that from the drawing also. We look at the foundation drawing. We see that above the rammed earth is still here. We have 150 mm sand filling. and this is 150 mm, and we have to convert it into meters, and so it becomes 0.15 meters. So that is item number 10, sand filling under floors. Next is item number 11, cement concrete 1:3:6 for 75 mm thick. So for that we again refer to the foundation section. The dimension of the the inner dimensions of the room, that is maintained as it is. So 7.8 and 3.8 is the same for the cement concrete also, because this is only within the four walls of the room. This what we are discussing now, the rammed earth and cement, the sand filling and the cement concreting for the base of the flooring, is all only for the internal dimensions of the room. So 7.8 by 3.8, and then we have 75 mm, which is 0.075 meters, because we have been using the unit meters. So we take it as 0.075. The next is the flooring material. So this is cement concrete flooring, 38 mm thick. That has been mentioned here. Again, we take the internal dimensions of the room, 7.8 by 3.8, and then we know that it is 38 mm thick cement concrete flooring, and so for our purpose we use it as 0.038, because we are using the measurement of meters. So that is the substructure. We've been looking at how to take the quantity of the substructure. Now we move on to the superstructure, and we will be looking at the dimensions of the doors. The next item that we are looking at is the wooden frames in doors. This is item number 13, and it has been specified that the frame size of the door is 75 mm by 100 mm, and we are looking at the door, single door that we have in the section, and in order to find the total length of the frame, we know that we have to find the height of the door and the width of the door. So the height of the door, as we can see in the drawing, is 2.13. The height of the frame is 2.13. So one side of the frame, the length is 2.13, and the width of the door frame is 1 meter. So this length is 1.1 meters, 1 meter, and then we have the 2.13 on the other side. And we don't have a fourth side for a frame, so we just have 3 sides. So which means 2.13 plus 2.13 plus 1, which is equal to 5.26. That is the width of the length of the outer frame of the door. And since we have 2 doors in the drawing, we take the unit as 2, and the length is again 5.26. 0.1 is the 0.1 is the thickness of the frame that has been given to us, 75 mm into 100 mm. So 100 mm is 0.1 meters, and 0.075 is the dimension of the wooden frame that is given to us, 75 mm. So that is 0.075. So that's how we get the quantity of the wooden frame. Now we are going to look at the wooden frame in the windows. So for this we have to again it's specified that the wooden frame in windows is 75 mm by 75 mm, and for this we look at the first we find total length of the wooden frame. So we know that let's look at this window. The width is 1 meter, so 1 plus 1.38 is the height of the window. Again 1 meter plus 1.38 meters. So that is the length of the dimension, the length of the wooden frame. So it becomes 1 plus 1 plus 1.38 plus 1.38, which is equal to 4.76. We have 4 windows in the room, which we saw in the plan earlier. So we have 4.76, and 0.075 and 0.075 are the dimensions of the wooden frame that has been given to us. The cross section of the wooden frame is 75 mm by 75 mm. So converting them into meters, it becomes 0.075 into 0.075. The next item that we are going to look at is item number 15, Fully glazed shutters for window. So inside the window, the shutters are glazed, and we're going to find out the dimensions of the shutters. Again, the number of windows is 4, and so we mention it as 4. In order to find the glazed surface, what we look at is the what is the inner width of the inside the frame. So it becomes 0.85, and we can see it from the drawing. It is 0.85, and the inner height of the shutter is 1.23. So for the fully glazed shutters, the area, the unit is square meters, and so we have the length is 0.8 meters and the height is 1.23. Now we look at wooden shutters for the doors. This is item number 16. Again, because we have 2 doors, we take the measurement as 2. We take the number as 2, and the area is square. The unit of measurement is square meters. And we're talking about the shutter and not about the frame. So we exclude the frame of the door. And excluding the frame of the door, the width of the shutter is 0.85 meters. So we have 0.85 meters. Now the height of the door is 2.05. That is excluding the frame. So 2.05 is the shutter height. So we have 2.05 in the column of height. Next we have cement concrete skirting. It is not shown in the drawing, but it's of height 0.15 centimeter. It's 0.15 meters thickness, and the 23.2 is, as we know, the internal perimeter of the room. So we have the CC skirting as 23.2 and 0.15 as the height. Now item number 18 is 15 mm cement plaster finishing for internal walls. So item number 18, 15 mm cement plaster finishing in internal walls. So for this, we again have the internal dimensions of the room, 7.8 plus 3.8, that is the total perimeter of the inner walls of the room, multiplied by, when it is multiplied by 2, then we have 23.2. So that is the total length of the room interiors. And we know that the height of the room is 2.9 meters that we have seen from that we can see that from the section. So the inner dimensions of the room, the perimeter of the room, into the height of the room, that is the quantity of cement plaster finishing in internal walls. So we have 23.2 and as the length, and the height is 2.9 meters. And that is the entire wall of the room. Now we need to deduct for the doors and windows, and we have 2 doors, and we know that the height of the door is 2.13 by, and the width of the door is 1 meter. So 2.13 by 2.13 into 1 will be deducted. That is the deduction, and then we multiply by 2 because there are 2 doors. So this is a quantity that will be deducted. Similarly, for windows, there are 4 windows, and what we do is we deduct the area of the windows from the plastering area. So again, the width of the window is 1 meter. As we can see from the drawing, the window width is 1 meter. And so the quantity that we need to deduct from the cement plastering is 1 into 1.38 into 4. So this whole area is where the plastering takes place. And from that, the spaces for the windows, both the windows and the doors, not both the windows, there are 4 windows, and doors are deducted. Next, we look at the cement plastering finish for the exterior walls. And for exterior walls, we have the dimensions. We look at the dimensions of the room again. For the external walls, we know that the dimensions are 4.2, 8.2, 4.2, and 8.2 again. So the whole perimeter of the external surface is 4.2 plus 8.2 plus 4.2 plus 8.2. So for the purpose of exterior plaster finish, we will be taking this dimension. For the plastering surface, when we have we have the external surface for plastering, that is 24.8. That's the perimeter of the external wall. And the height is, how do we find the height? So the way we find the height is, we know that from the top of from the terrace level to the plinth level is 3 meters, and then the plinth height is 60 centimeters. So the total height of the room is 3.6 meters. And from that, we deduct the thickness of the slab. We're not considering we're not plastering the slab. And so we have 3.6 minus 0.1, that is 3.5 meters as the height. And again, similar to the previous case, we deduct for doors and windows, same as in the case of internal plastering. And we have 2.13 and 1.3 deducted for doors and windows respectively. Next, we're looking at whitewashing. This is same as item number 18, which is the inner plastering. And in this, for the interior, we add for ceiling. So for the ceiling, we have to find out the inner, basically we are looking at the inner dimensions of the room. This is the same as a ceiling dimension, which is 7.8 by 3.8. Now, color washing outside, same as item number 19, which is the cement plastering of external walls. So for that, we do the same as item number 19. Now, the next item that we are looking at is painting of doors and windows for door shutters each side. So for this, we have 2 doors and there are 2 shutters for each door. There are 2 doors and there are 2 sides to each shutter. There are 2 sides to paint, and so we find the width of the shutter, which is 0.85, and the height of the shutter is 2.05. So the painting of door shutters on both sides is 2 into 2. One is to represent the number of doors, and one is for the shutter, number of shutters. So the sides of the shutter, 2 into 2, and 0.85 and 2.05 are dimensions that we get from the drawing. Next, we look at the door frame. Next, we look at the door frame and painting of the door frame. And first of all, we look at the front side of the frame. There are, we take the factor as 2, and then we have 5.26 as the length. How do we get that? For that, we look at we're talking about outer frame. So we have 2.13 as the height, and then we have 1 meter. We add that, then we have one more height. So it becomes 2.13 plus 1 plus 2.13, and that becomes 5.26. We know that the cross section of the frame is 0.075 into 0.075, and so we take the dimension as 0.075, and that becomes the input for the painting of the door frame. Now, because there are 2 sides to it, the inner and outer side of the door frame, so we multiply it by 2. Similarly, for the rear side of the frame, we have again 5.26 and 0.075, and we multiply by 2, whereas here 2 is the number of the doors that we have. This is the case in the previous one also. I had wrongly mentioned it as both the sides of the frame. That's not the case. This represents the number of doors we have. We have 2 D1s. Next, we have rebate side of frame. And we know what the rebate is, the inner portion of the frame. And for this, what we do is we find that again 2.05, and 2.05 is the inner dimension of the frame, the inner dimension of the door, and then we have the 0.85 as the inner frame to frame width. And so that is also added. So this is the rebate side. The rebate side is taken as 2.05 plus 0.85 plus 2.05 meters. So that we get 4.95, and the thickness is 0.1. Now we look at the window frame, and for window frame what we do is we find the dimensions. We have 4 windows, so we have the number 4 in all. In the similar way, we find 4.76 is 1.38 plus 1 meter plus 1.38 plus 1 meter. We look at this window for clarity. So we get 4.76. Similarly, the cross-sectional area, we have the frame width as 0.075 and 0.075 in both the cases. Now for the rebate side of the frame, it's 1.23 plus 1.23 plus 0.85 plus 0.85. For the rebate side, we'll be looking at the inner dimension of the inside the frame. So 1.23 and 1.23 on one side, then 0.85 of one side, 1.23 again, and 0.85 again. So we get 4.16, and we have the cross section, width of the thickness of the frame as 0.075. So we get that in the thickness part. So because there are 4 windows, we multiply it by 4. The next is bitumen painting on top of the slab, and for this we take the outer dimensions, which is 8.4 and 4.4, that is measured in square meter. We did not mention it here. It's measured in square meter, and that is the square meter area of bitumen painting. Similarly, for lime concreting and terracing, which is for 10 centimeters thick, we again have the same dimensions, 8.4 and 4.4. And then we have the square meter area, the unit of measurement as square meter area. So to summarize, in this video lesson, we were looking at taking the quantities of various items in a building, and we went into the detailed aspect of it. And our video lesson was split into 2 parts. In the first part, we discussed up to the brickwork, the measurements, how to take the quantities up to brickwork, and the remaining of that we saw it in our second video. So when we go back and see how we did today's video lesson, we first looked at the various plans and drawings that were given to us, and we had a plan, we had a section, we looked into plan, and then we looked at elevation. We looked at the section, and then we compared, we found out the information that were available. We also looked at the footing, the section of the footing, as to find out what was the dimension of quantities below the substructure. And from that, we took the information available. We took all the information available to find out quantities. And based on this, we arrived at various quantities on an Excel sheet. So that was our video lesson for today. We'll see you in the next video lesson.